Okay. This program is to interface an ultrasonic sensor with Raspberry Pi and measure the distance, how far the object is from the sensor. So required materials, you require Raspberry Pi, the ultrasonic sensor, Tony IDE, and Python interpreter installed. Some of the features of ultrasonic sensor. The key features of this ultrasonic sensor is the operating frequency, 5 volt. It runs. The sensor runs at 5 volt supply, and the operating current required for the system to be enabled is 15 milliamps. The measuring range starts from 2 centimeter to 4 meter. The accuracy, 3 millimeter of accuracy you can get it, and the trigger input pulse, and you have a echo output signal. So at the trigger input pulse, this pulse we send it from microcontroller to the ultrasonic sensor to indicate that it is a start of transmission. Then the TTL pulse, this is a pulse which is received through the echo line, and using the pulse duration received through this echo line, we are going to measure the distance, and the formula for finding the distance is given by this. Distance is equal to speed of sound, which for ultrasound signal, the speed of sound is 343 meters per second, or in terms of centimeters, it is 34,300 centimeters per second. Multiply with the pulse duration and divide it by 2, because this is due to the fact the distance which we are going to get here is double the actual distance between the sensor and the object. So basically the way this is gonna run is you have a Raspberry Pi module, and this Raspberry Pi module is connected to ultrasonic sensor, and the pins are VCC, ground. Then you have a pin which is echo, and another pin which is this is echo pin, and this is trigger pin. So trigger pin is we can set it to any. So let's say that time being the trigger pin is 11 and echo pin is 12. Okay, this is the connection between Raspberry Pi and ultrasonic sensor. So initially what you have to do is to make the communication between these two systems, you'll be sending a pulse with the duration 10 microseconds. So turn on this line, which means this is a pin number trigger, which is, let's say 11th pin is a trigger. So through pin number 11, create a delay with 10 microsecond. That indicates it is a start. It's a start of the start pulse. After that, the DHT, this ultrasonic sensor, is gonna emit a high frequency burst of signal. So this kind of a high frequency burst of data is transmitted from the ultrasonic transmitter. So that's gonna give you a signal will be transmitted, and let's say that there is an object here. So this will be transmitted, and the same signal is gonna be reflected back. You're receiving the same signal, and this signal will be received through ultrasonic receiver. And basically what you do is to find how far the object is from the sensor module. You'll be finding this duration, time taken to travel the signal from this position to the object, and again the time taken for the same wave to travel back to the sensor. So altogether this time is 2 times actual distance, or 2 times the pulse duration. So this time, that is time taken from the time taken for a pulse to travel from sensor to the object, and time it takes to travel it back to the sensor, the whole time duration is considered, and this time duration will be used for finding the distance. And this time, during this whole time till you hit this pulse to the object and receive it back, this kind of a waveform will be generated at the echo. So echo line is gonna receive this kind of a pulse. It will be high for this much time, this much seconds, and that is used for finding the distance. So we find the distance formula by using speed of light multiplied with the pulse duration, and we know this pulse duration is 2 times the actual duration, so we divide it by 2. So that's how we measure the distance, and this distance in centimeter is estimated. So the program logic goes as follows. So pin number 11 acts as trigger pin. Pin number 12 will be acting as an echo pin. Speed of the sound is defined as 34,300. We define the mode. So here make sure that this is board now, because we are using pin number 11 and pin number 12, which means this should be board. If you are using BCM, make sure that this is pin number 17 and pin number 18, then it will be fine. So make sure this mistake has been corrected, otherwise you will not be getting the result. Then the trigger pin is set as output, direction is set as output, and for the echo pin, direction is set as input. Now first, this is a distance measure program which we have. In fact, what it does is, initially, as I said, trigger pin is pulled low. That's to make sure that you're supposed to create a high pulse of 10 microseconds. For that, initially we make sure that the sensor is getting settled. So make the pin 0 so that it is stabilized. Then you're sending high and you wait for 10 microsecond. Then you make it fall. So that's the high pulse, which with a delay. High pulse with a delay. That indicates the start of the pulse. Now after that, we record the time, which indicates what's the start time. So as I said, the moment you send 10 microsecond signal, the signal from the transmitter, ultrasonic system, is going to be transmitted. So record that time, exactly time when the burst of signal has been transferred. Record that time, and here we wait. Is it what you are receiving 0 here? So now let me assume that we have 1. So in which case this code is not gonna execute, and pulse end is the time which we take. So here we find till what extent echo pin gives you 1 signal, and this time is recorded. That gives you the pulse end time. So pulse end time is nothing but how long the echo pin goes 1. So that pulse end time is recorded, and finally we find the pulse duration as the pulse end minus the pulse start time. So after measuring this pulse duration, we multiply pulse duration with the speed of the sound, and we divide the whole number by 2, and this distance is returned back. Now in the program we write while true. So try and except can be used to handle exception properly. So here we have a while true, which means that's this code is going to run forever, and we call a measure distance function, which returns the distance which has been available in this variable, and we print it with 2 digits of the decimal points. Then we add a delay of 1 second. Then this is required only if there is a keyboard interrupt added while running the program, and if you want to stop the program forcefully, you can use this command. Even without this, the program is going to run. Finally, here we add cleanup function. This will make sure that once the program is terminated completely, all the pins, whatever the values are set initially, everything will be flushed off. That's for resetting all the pins, so that next program can be run there. So this is the program for interfacing ultrasonic sensor with Raspberry Pi and measuring the object distance.